slide. All right, so what we've seen so far has been a lot on how to get ready, how to get kind of set up with the system, how to maybe build a custom model, port something over from Hugging Face. What I think we'd like to do a little bit now is to just show you what happens at the tail end of training, right? How do you actually now go in and maybe monitor how a run went, and then of course also profile your code to understand what's taking a little bit of time, what needs to be made more performant. So there's a couple of options that we offer for these things. So let's start with monitoring, and I'll walk you through what it looks like, and this will become easier when we do the hands-on sessions for you to get a chance when we have actual run logs and things like that. But let's say you are now inside your user node, you have logged in, you're SSH'd into the system. You can then activate your Python environment. Just go ahead and get that ready, right? And here's a command here that you can use to get that started, fairly standard. And then what we do is we can launch TensorBoard by pointing to your training directory, right? So that's the second, the command that you can see there. After you point to your training directory, make sure that you bind that to the local port on your computer. And as part of step 3 now, what you can see again here is once you SSH into your user node and you can kind of bind the ports there, you will see a pop-up on your screen, and you can go to the, in your local browser, if you navigate to localhost 6006 or whatever port that you've binded it to, you'll be able to see the results of that latest run or whatever the latest run is inside your train folder. And so if you can go to the next slide, Sylvia. Great, so this is an example of what that might look like. Well, you'll be able to see a number of different parameters, including here, we're looking at the average samples and average steps. So whatever you've logged there, you'll be able to see inside TensorBoard on your screen. So really quick and easy, quick and dirty way to monitor runs, very easy to do, very easy to set up, as long as you have access to the user node, and you can kind of set up TensorBoard in this way. Can we go to the next slide, please? All right, great. Now there's a couple of other things that users will typically want to do. You want to be able to quickly see what are all the jobs that are currently running, and then be able to maybe cancel a job that's under your username and that's maybe been running for a while, or it's stalled. So the way to do that is to use this utility that's kind of provided out of the box, CS-CTL, and you can use this inside of any instance that you've SSH'd into. So you will be able to run CS-CTL, get jobs, and the output of that will be, as you can see in the first section here, you'll get a list of all the jobs that are running. And you can also see all the jobs that have run kind of historically as well. So if you do get jobs, you'll see the currently active jobs, and the status can either be queued, running, succeeded, or failed in this case. And if you do get jobs -A, that'll get you all of the jobs that have run, even including historical ones. And then very easily, if you want to cancel a job, just simply pop in the job ID, as you can see here in step 4, CS-CTL, cancel job, and then you can kind of put in the name that you might have captured using the get jobs function. So again, a very easy utility to quickly monitor what jobs are active, what jobs have been running and maybe have failed. And as you do this, you can then go ahead and cancel those as well using this very easy utility. There is more documentation, again, that's available, so you don't need to look through these slides only. In our docs, in our dev site in docs.cerebras, you'll be able to find a whole section on the other functionality that's available with this utility, other kind of arguments it takes in, and a full reference there as well. We can go to the next slide. Great. So in addition to, of course, monitoring your runs and the performance in that way, you do want to also be able to check the trace and profile your code. There's a couple of different things that are important to note here. We do have a CS Torch profiler that's available. It's in beta. So there's a couple of capabilities that I'll note here, and as well as a couple of limitations that we'll be addressing in subsequent releases. In terms of capabilities, this profiler allows you to walk through your CS Torch API code that you've put together and it highlights the 10 most time-consuming modules, the 10 most time-consuming PyTorch modules. It kind of gives you an idea for how those modules are performing, which ones are taking the longest time. The other thing that this profiler gives you is a JSON file that you can pop into Chrome's tracing tool to get a full play-by-play of all the operations that have sort of run as part of your profiling of your code. A few limitations to note here. First is that today we only support wafer ops, so ops that have run on the actual wafer scale engine. We do not currently support ops that are running on the host server. So that's one thing to note. This is coming in very soon in our subsequent release. As well, the main mode that this supports today, the profiler, there's a few different modes that you can run your training jobs in, one being train mode, eval mode, and then train and eval mode, which we'll go into in some detail in a later part of today's presentation. The profiler only works with the train mode as of now. Additional support is coming soon. And if Sylvia, if you're able to click on that link, this document, we can actually share with you after the presentation, and it includes a lot more details on step-by-step, what are some things that you can do with the profiler, and maybe the document's not opening, that's okay, we can share it after the fact. But suffice it to say, there is, again, more detailed documentation on what are the steps you can run, what are the outputs of these steps, how to dump the trace file, the trace JSON file that's given as part of the profiler, and kind of visualize in the Chrome trace tool as well. So all those steps are sort of documented. We can share that with you after our presentation. Can we go to the next slide, please? All right, great. So just a couple of things to walk you through at a high level what you can do with the profiler. You can profile if you're using a model zoo model that's kind of pre-built out of the box. There's one way to do it, and then there's another way to do it if you're going to step through and kind of feed in the profiler at various points in your CS-Torch API code. That is detailed in our documentation. In this example, I'll kind of walk you through what you can do with the model zoo repo model that you might be using, the reference implementation. So the first step is to make sure to obviously clone the repository, and then you can navigate to the actual model that you'd like to inspect. And there's an example seen here. You can cd into the model zoo config folder for, in this case, GPT-2, which is inside the NLP folder inside models. And then what you want to do there is to go to the model configuration, and under the run config section, you simply just specify how many steps for which you'd like the profiler to run. So you can specify op profiler config, as you're seeing here in step 3, provide a start step as well as an end step, and that's all you have to do. Now, when you run train, and again, when you run it in train mode, the profiler will be active in the background. And as you can see here, it'll run for steps 1, 2, and 3. Those are the ones that are going to be profiled. The output here is going to be a log in your console, as well as the trace file. Now, if we go to the next slide, we'll actually get a chance to look at what that output looks like. This is what's outputted immediately after the training. As you would typically run training, you just hit the run.py script. You've trained your model now, and because you specify that you want to run the profiler for the n number of steps in the run config, this is the output that you see in the console. It'll give you, again, the top 10 PyTorch modules in terms of the time they've consumed. And you can see here, you see the module name. You also see the amount of time on the CSX system, as well as the percentage of overall time in execution. So kind of a neat little utility, again, to get a sense for what's going on, what's taking a lot of time, and give you the ability to then go in and debug and figure out what you want to do next with the model. And I believe that is the last thing I wanted to share